I'm good. All right, let's get it started then. Good afternoon. Thank you so much for having me. I am super excited to be here today. Again, as Bruno mentioned, I had the pleasure of founding this conference with him 10 years ago, and wow, it's been 10 years. I am here to talk a little bit about AI, and I can already hear some groaning in the audience. Yes, we're going to talk a little bit about AI, but I'm going to try and talk a little bit about reality. Just to give you a little bit of context, my name is Tiago. I work for a company called Coalition. We sell cyber insurance. However, we are not your typical cyber insurer. We scan the entire internet. We run large networks of honeypots. We do a lot of technical work when doing underwriting. And we found that we needed some help from AI to do some of the things that we do. I run the research team. Let's dive in. So my objectives for today is to show you what is possible reality, day-to-day use cases with AI. My second objective is that you walk away from this presentation wanting to try some of these things and thinking about when you go back to your jobs on Monday, hey, could I try this thing? Could it make me better? And by the way, I don't know about you guys, but at least what I found is if you use AI, it can accelerate you, meaning you can be lazier and still get paid the same. And that typically tends to be a really good thing. So let's go back to basics. Before I dive in super deep about the use cases, I wanted to at least give you a foundation of AI. If we go back to November 30th, 2022, OpenAI introduced ChatGPT. One mistake people make is thinking that ChatGPT is everything. ChatGPT is actually the application layer that sits on top of models called the GPT models. And this is what all of you used. The other thing that I would like to point out is it's been a year, pretty much. It hasn't been that long. So as you're thinking about and seeing my examples today, don't think just about today. Think about that it's been 1 year, and this is where we are. Imagine where we're going to be a year from now, 5 years from now. There are 5 things that I would like you to know when it comes to AI. And I will promise you that I am not going to use a single mathematical formula because we're security people, we're security engineers, we're developers. There are ML engineers that can take care of the mathematics. We're going to focus on practical aspects of this thing. Large language models. They're essentially general purpose machine learning models. Imagine having a pile of books. The books are not from a specific vertical. They're not just medicine books. They're not just law books. They're just books, a really large pile of books. These are essentially texts that were found on the internet, that were scraped, that came from books, and those were used to train these models. These models can also be trained for fine-tuned purposes. You can think of this as owning a dog. You can have a normal dog, but you can also have a dog that's trained to be a cop's dog, to help a cop. Or you can have one dog that's trained to sniff drugs, or you can have a dog that's trained to compete in agility. It's the same thing. That's like fine-tuning a model. You essentially have this thing that learns a very specific set of skills. The large portion has to do with the training data sets that are used to train these models, and also the number of parameters that these models get. The other important thing is GPT isn't the first or the only one. Over time, there's been lots of different models released from Google, from Meta, open source models, Anthropic. So yes, use OpenAI, it's great, but don't buy fully into the hype. There are cheaper ways to do these things. You can even have models running on your laptop, which comes with a lot of privacy benefits as well. As parameters grow, so do the use cases that these models can do. In the more simple ones, it's typically language predictions, so it can essentially generate text, or it can act as a chatbot. In more advanced models, they can write code for you, they can generate images, lots of interesting things that a model can do. The other thing as well that people tend to confuse is thinking that this is just about text. This isn't just about text. GPT-4v, which was launched by OpenAI a couple of weeks ago, is actually the first multi-model launched by them, meaning you can feed an image to a text model. And this allows you to do really interesting things. So the image I'm showing you on the right is from our internet-wide scans, and we caught a VNC, so remote managed computer that was running VNC, which is a management protocol that was open to the internet. There is a tiny problem though. I don't speak Japanese. So when I find these things, I'm actually really curious about what is this thing? And I tried to ask GPT to help me. And all I did was give it the image and ask it, please describe the attached image. And immediately GPT started doing that. It started explaining that there is a specialized tablet called TNC 5000. It grabbed the portions that were in Japanese and translated it all for me. And then at the end, even made a note that there's something weird with this device because the units of speed and noise appear to be incorrect or may be a specific notation used by this type of device. So this is really, really cool for that a machine learning model. I am able to give it an image and it handled translation, interpretation, summarization, all for me in a couple of seconds. Prompting. Just how you go into Google and you type a query, prompting is how you interact with these models. And prompting can change how the model is going to act and what the model is going to do for you. We have two examples here. On the left, I ask, is there a vulnerability in this code? And I paste a bunch of C code, and it essentially gave me a list of the vulnerabilities that were present. And on the right, I said, write me a secure version of this code, no prose, don't explain anything, just give me the code. And it just started writing a more secure version of this code still in C. So prompting is essentially how you ask things out of this model. Embeddings. Embeddings is when you grab a piece of text and you essentially translate it into a numerical vector. So if you want one of these machine learning models to understand some of your personal data that the model has not been trained on, you essentially convert this to embeddings, and then you're able to use that data with the model. And it essentially allows you to do distance similarity, because it clusters these sentences because they become numeric vectors. It allows you to do clusters of similar things. So a man walked a dog, and a man and dog are walking, those two sentences would automatically be close to one another. Retrieval augmented generation. So these models are trained on very specific data. But if you want to use your own data or updated data that is not being trained in the model, what you do is you build a database of embeddings, and when you're querying, you're first going to query the database of the embeddings, pull information that's relevant, and then you're going to feed that relevant information into the model on your prompt. So if you're prompting who walked the dog, if first query would be into a database looking for walking dog, it would pull all sentences related to walking a dog, and your prompt to the model would go with all those sentences and your question, who walked the dog? And then the model would respond, the man walked the dog. And then there's agents. You can think of agents as all the things that I explained before, but then you also give them tools, meaning you can have an LLM that has access to Bash, that has access to a browser, that has access to whatever APIs you guys can think of or use on your day-to-day. And agents are the future. This is a modern AI stack. If you want to experiment at home, there's a bunch of different LLMs. There's frameworks to interact with the LLMs, and there's also the vector databases where you can store those embeddings. Congratulations, you're all AI experts. This is it. I know the AI people are going to hate me for this, but you make it way more complicated than it actually needs to be. So let's start talking about what is actually viable. Honeypots. And I'll switch here real quick. So as I mentioned before, we run a fairly large network of honeypots. To give you an idea, just in the last 30 days, we saw 46.3 billion events against our honeypots. And events are malicious exploitation, internet-wide scans, all sorts of things. And you can see here on the right that we build tags to automatically classify these events. Now, this requires a lot of work. And I'll go here into a quick example. Just to give you an idea, for example, on November 1st, we saw 27,531 payloads that we had never, ever seen before. And this happens every single day. Now, think about if you're a security engineer, having to grab every single one of these payloads, having to go into Google, understand if it's exploiting a CVE or which technology it is associated with, and then write a rule to tag those payloads. It's a lot of work, and honestly, no matter how many security engineers I would hire, I would never have enough to be able to just keep up with everything that's happening. So we essentially turned to AI to help us out. We have our honeypots. We have a rules engine that automatically tags all these payloads. All of this gets stored in BigQuery. We do our anomaly generation, meaning we look at all the payloads we received and select only the ones we've never seen before. We then group them together because often we see payloads that are fairly similar and have just a dynamic portion where they're trying different usernames, for example. We then pass those to an AI agent, and the AI agent using the Google Search API and an LLM is automatically going to generate the rules for us. Right now, we are not automatically merging these rules in. It feeds a web application where we then have a security engineer that just says approve, not approve. When one is approved, it generates a PR into our GitHub and new rules are generated. And I'll show you a quick demo for this. So if we're looking at this day, for example, I'm gonna pick this payload. I'll need to go get the full payload from here. And this is AI, so if my demo fails, you don't get to throw stones because these things are unstable sometimes. And I'm gonna paste the payload here, and we're gonna give it a second. And essentially what this is doing now is breaking the payload into parts and then using a combination of Google queries to try and guess what it is. And as you can see here, it says that it is associated with F5 big IP, it is considered malicious, and it also generated the rules to automatically tag these things. And the other interesting portion, you might notice, it removed it tried to create as generic a rule as possible to cover as many payloads as possible, because it essentially removed the dynamic portion of the payload, the user that was being attempted, from the rule itself. And the great thing about this thing is you can just eat through these payloads nonstop. So instead of me having security engineers day in, day out, sitting, looking at these things, we no longer need to. You can just have AI help us tag these payloads. As an example of the benefits of this, many of you might have heard about CZAID that just came out this week, that Lockbit, the ransomware group, is using a zero-day in CZAID. We actually observed scanning on our honeypots for CZAID all the way back in March 15th. So when the vulnerability was disclosed this month, it was super easy for us to just go on our honeypots and ask, how do we see anything related to CZAID? And because it was tagged, it was super easy for us to then turn it around and use these same payloads that people were using on our scans to identify which of our clients were exposing CZAID to the internet. But we didn't have to go drill into the payloads, try and understand how the payload works, because AI had already tagged these payloads for us. You can think of this as essentially searching for a needle in a haystack, and the haystack is really, really big, because as I mentioned, we get 40+ billion payloads every single month. This is an example of a PR that's generated by the LLM into our GitHub repos that then still gets approved by a human, but we're hoping that by the end of the year, this is going to be fully automated and humans in the loop are no longer required. Over time, one interesting thing to see is the growth in our honeypot tags. So to give you an idea, if you look at when we started using GPT honeypot, which is what we call this system, it took us 12 months with just humans to go from 300 to 400 tags. But we went from 400 to 500 in just 4 months. And that's still using human approval. There's nothing stopping us from tomorrow having this fully automated and have a massive increase in the number of new things we're able to observe. Oh, and by the way, it's not just giving us new things. For the things we already knew about, it fine-tunes our rules. Because sometimes, let's say, for example, that a new type of attack, for example, Log4j, GNDI, it started with just GNDI. Then it was one uppercase, one lowercase, one uppercase, one lowercase. It covers these things as well automatically for us. Second use case, source code analysis and web application pen testing. It works just like a human. The more you can give it, the better it will work. And as you remember, I mentioned before that GPT is multimodal now, so images are also useful. And I want to walk you through an example here. So in the beginning here, I attached the zip code with the source code for a web application. I'm using the OWASP juice shop as an example here. And I also give it a text file with the URLs from the spidering of the web application. It immediately found a potential vulnerability, cross-site scripting. It writes a proof of concept, and then I ask it, show me the proof of concept URL. And then it tells me to test it in the user profile. And I just continue to ask it, I test it, it actually didn't work. I give it a screenshot to show that it didn't work. I ask it, give me some more examples with obfuscation. The LLM automatically generates cross-site scripting examples with obfuscation. I'll let the video keep going. I also gave it then a screenshot of the main menu, as in the profile that it asked me, it didn't work. Asked it, where else could I test it? It asked me to test it in the search function. I pasted the payload, and it still didn't work. And I gave it the screenshot and told it one more time, it didn't work. I asked it, can you give me 10 more examples that I can try? In the search functionality, it gave me some more. And then, go a little bit forward, the cross-site scripting triggered, and I gave it the screenshot and said, I just said this was the output. And it replies, based on your description, it sounds like one of the payloads successfully triggered, which means the payload was not properly sanitized. It gives me the full description. And essentially, I was able to find a cross-site scripting. The cool thing about this as well is I can then just ask it, write me a report for the maintainers. And essentially, it will give me a fully written report describing the vulnerability, steps to reproduce, all those things that, honestly, as a pen tester, I hated doing because it was boring as hell. So it can find vulnerabilities. It works fairly well. Let's see if I can go back to presentation mode. There we go. From my personal research, I would consider GPT-4 is like an analyst for code, for network packets, with 1-2 years of experience, but with the writing skills of a senior. I've been testing against a bunch of open source software, and up until now, I've been able to find 2 new 0 days in Boa server, which is an older web browser, but that is still heavily used in embedded software, and I was also able to find a no day in Redis. The one thing that I will say is the version I use in my research is more agent-based, is not just pasting things in ChatGPT as I did in my example. So what that means is I give it access to a server that has the software running, and it can automatically test the payloads that it's producing against the software, detect if the exploit was successful or not. So I do a couple more shenanigans to essentially automate and run this thing at scale. I'll leave it to you up to set up a pipeline like that, because there's fun things that can happen with that. I also created a custom GPT for source code analysis. You are more than welcome to try it. All you got to do is have a zip file with source code, throw it into this GPT, and ask it to find the type of vulnerability, and it's automatically going to start to do its thing. PCAP analysis, for those of you that do networking. There's some limitations. If a library doesn't exist in the environment, the LLM can't just install it. But if that happens, it can still act as a co-pilot, meaning it will ask you, can you please install it and give me the output? So as an example here, I gave it a sample1.pcap, and I told it, hey, here's a network that is under the DOS attack. Please analyze it, find out what's causing the DOS and the type of DOS. Also generate some supporting plots to go with the analysis. It gives me errors because it essentially doesn't have SCAPI installed to be able to analyze the PCAP, but then it tells me, hey, you can write some Python code that reads the PCAP, exports everything as a CSV, and then I'll be able to analyze it. But of course, I am super lazy, and I cannot be bothered writing Python code, so I asked it to write the Python code on my behalf. So it writes the Python code, then all I needed to do was copy-paste it, run it against the PCAP, and then I give it the output.csv, and it immediately starts the analysis. It lists all the fields, what the fields are, and then starts doing frequency analysis, finds the IPs that were DDoSing, causing the DDoS, looks at the traffic patterns, looks at protocol usage frequency, and it essentially tries to guess what type of DDoS was being used here. And again, I can hear you in the audience saying, yes, but let's advance here again. Google Meets is not a fan of videos. There you go. Yes, I know your CM and log management platforms can also do pretty graphs and can do all of this. But the interesting thing with GPT is that we can also do this, where I gave it a different CSV, where there was exploitation actually happening. There was a vulnerability being ran from one machine to another, and I said, please tell me which vulnerability is being exploited in this traffic. And it essentially did analysis. It concluded that, hey, looks like there's heavy traffic, SMB on port 445 based, SMB on port 445, and typically when we see this type of thing, and based on the payload, it is MS17010, essentially eternal blue, if I'm not mistaken. And it was indeed that the type of attack that was happening on that PCAP. So again, as a support analyst, not fully automated, GPT is pretty useful. We are working on what we call a security co-pilot. You can think about it from our perspective. As I mentioned, we sell cyber insurance, and when you buy cyber insurance from us, you get access to an attack surface management platform. But on top of that, because we sold you cyber insurance, we have a financial incentive in your company not getting hacked. That means we need to give security support at scale. And to give you a notion of what scale means for an insurance company, we have 100,000 customers that we need to give security support to. And our security team is about 20 people. So we're turning to AI. We launched the first version of our security copilot, and if you remember from the beginning of the presentation, I talked about RAG, where essentially we fed a bunch of information, the typically asked questions, into a bot. But what we found is that actually it was pretty limited, because anytime there was a question that wasn't in our knowledge base, the agent would fail to answer. So we're working on a new version. The new version is based on agents, meaning it has access to Google and is able to look up information, and therefore is not limited to the knowledge we fed to it. It also has access to our customer information, and typically when you buy cyber insurance, you have to tell us things like which EDR do you use, which backup solution do you have, how many office locations do you have, and that's all super useful information when giving security advice. And I'll try to do a quick demo here. So for example, if I say hello, I have an RDP exposed to the internet, and I have a sonic wall firewall. I would like to remove the RDP from internet exposure. Please tell me how. And this is still super early beta, so it might fail. But we'll give it a go. We'll see what happens. What's happening in the background? The agent is breaking down the sentence, is going to the Sonic Wall website, is essentially gathering the Sonic Wall documentation, and it's going to try to give step-by-step instructions. I can also try to ask it for more detailed information. Can you give me step-by-step instructions? What if it's a Fortinet firewall? We'll see what happens. But it's essentially, it's Googling the information about these devices, going to the documentation, downloading the documentation, understanding that we're talking about RDP, learning what RDP is, learning the associated port with RDP, and merging all these things into a concise answer. So as you can see, navigate to policy and objects, IPv4 policy, it knows the port for RDP is 3389, and it gives step-by-step instructions. And this works for any types of questions that Google might potentially have an answer for. What our objective here is not that this becomes the AGI for cybersecurity. It's just that as we think about our tier 1 security questions, the basics, that AI takes those and we can have humans focus on tier 2 and tier 3 that are a lot more complex. Because we have to think about scalability. CV analysis. We launched a website, ess.coalitioninc.com, that has a vulnerability categorization and prediction modeling, where essentially we try to predict out of all the CVs that come out, which ones are going to have exploit code exist for it, and which ones is actually going to be exploited en masse. And where we use GPT for this is, if you see here the keywords highlighted on the right, what we have found is GPT is really good at removing the noise from the descriptions and only pulling out important keywords. So the important keywords are used as a feature in our big model, in our ESS model. So that's another example. Questions? Yes. I cannot hear you. Is there a microphone? Oh, there we go. Lapel.
Who is asking the question?
Hands up if you have a question.
So, you explained that when a prompt is converted basically to a numerical vector by sentence, am I correct?
No, the data that you want to feed into the LLM, you first generate the embeddings, and the embeddings are stored in the knowledge base.
Okay. That's completely... No, because I was trying to understand how the conversion to a numerical vector would, for example, help in the interpretation process. So, for example, I was imagining that the size or the direction of the vector would imply some sort of interpretation, and then what came to my mind was, so for example, if I finish my sentence with a dot, how would the AI know the difference between ending with a paragraph, which usually means a different topic, or just a dot and then continue the same topic? I'm not sure if I'm explaining myself correctly.
You are.
Okay.
But it's separate parts of the process. So what would happen is, when you send your first prompt, that's going to be broken down into specific words. Those words are going to be used to pull from the knowledge database similar content, and then everything is fed to the LLM, and the LLM will handle interpretation. And sometimes, yes, it breaks. Like, they're not perfect just yet. Adding a not at the end sometimes, for example, might break things, yes.
Okay, thank you.
Yes? Right here. Poor Paulo has to run back and forth.
Hey, great talk. I have two questions.
Can I get a hand up? Sorry, I do not know where you are. Oh, there you are.
Yeah, I'm here, yeah.
Yes.
So I have two questions. How reproducible are your examples? Even with the same prompt and with the same, let's say, code snippet, do you manage to get reproducible answers?
Can you repeat? I cannot understand the question.
How reproducible is the LLM's output when you give it the same prompt and the same sample of, for instance, code you wanted to review? How consistent is the output?
So these are generative AIs, so it's not always that you're going to get the same thing, and that is where prompt engineering comes in. There are two things you can change. You can change the temperature of the model, and the temperature essentially says how wild the model gets to get away from what you're asking, and fine-tuning the prompt and essentially saying no prose, output in JSON and JSON
I get that.
only.
My question is it consistent for you, and do you manage to get consistent results with the same sample and the same prompt?
You do, but it requires a lot of prompt engineering. It really requires a lot. You are able to, but it requires a lot of prompt engineering. And by the way, OpenAI saw that as a problem, and that's why in the latest version they released this JSON mode, because it was something people were really struggling, that sometimes get these LLMs to output valid JSON. But yes, it's a problem, but prompt engineering helps a lot.
Right, because I notice if I ask an LLM to output as JSON, like 1 out of 10 times it's like, nah, I'm just going to ignore your prompt. Do you notice the same thing?
We do, and to give you an idea, as we think about one of these projects, we don't necessarily spend the time training models. It's actually like fine-tuning prompt engineering, and we've built systems that essentially launch the same request with different prompts, and over time we're monitoring quality of all of these prompts to see which ones are more consistent. You need to have a lot of metrics to successfully deploy something like this in production.
Very nice. I'm definitely interested in this. Second question, have you tried other models such as Cloud 2 or any open source models?
We do. We have some things. So we have certain AI projects that we launched, and we didn't have our OpenAI enterprise contract signed yet. And to give you guys a little bit of context, if you're using customer data, do not use the normal OpenAI APIs. Sign up for an enterprise contract, because then you get zero retention and full privacy. Going back to your question, we didn't have our contract signed yet, and we wanted to proceed with some projects, so we have an internal bot that handles customer requests, more on the insurance side, that is an open source model. We trained the fast chat T5, we fine-tuned an open source model.
All right, thanks.
No problem. Any other? I think we have one here, Paul.
Okay.
Right.
Not your turn yet. You're going to have to wait a little bit.
I'm gonna get it back. Like, great talk.
Thank you.
Second talk about AI in 2 days, so this is pretty fun. So I want to ask about the plan is to then remove humans from the equation, the human acceptance of the results. What are the safeguards that you intend to put in place to ensure that the AI just doesn't drift off the rails and just start putting MRs that are dangerous?
So a couple of things. One is any project we start always starts with a human in the loop. And as the humans in my team are reviewing this payload, saying yes and no, that is fine-tuning. It's essentially reinforcement learning. It's fine-tuning the model again. Number two, we have a lot of metrics. Specifically, we know, we have canaries, meaning queries we know the result should be this thing, and we constantly run them and confirm that the result still looks the same. So for any project, you always need to build canaries. Number three, depending on the project, ideally you use RAG to stop hallucinations. And I'll give you an example. The absolute first AI project we launched was something that looked at the content of a web page and predicted what was the Nike's code, essentially the industry code for that company. We never noticed in the first few weeks, but the LLM was completely hallucinating Nike's codes. Like, he was telling us codes that it sounded super certain, but the codes didn't even exist. So what we did to fix that is we essentially RAG in the list of existent codes and tell it, you are only allowed to pick codes that exist in the list. And that essentially stopped all hallucinations of industry codes. But that's just, 3 things that you can do to reduce those concerns.
Thanks.
That guy is first. Yeah.
Hello, Tiago. Great talk.
Thank you.
The same question. I had the same question that the other guy did.
Oh, okay.
So it's answered. Just a matter of time.
There you go. Okay. But by the way, there is one question I get asked very often, and just for a second. Is this going to replace my job? Like, if you're in security, you have job safety. You're fine. Because guess what? These things suffer from injection. These things suffer from hallucination. These things suffer from escapes of the sandboxes. Like, your job safety is absolutely just fine. Your job might just shift a little bit. Don't worry about it. Yes.
Great talk. Back to the last slide that you shown. Can you elaborate a bit about the exploitability prediction that you have, like basic methodology, and have you benchmarked it, and can you share some results?
Yep. So the way this works is for any new exploit that comes out, we have a bunch of features that we pick. And we essentially compare those features back to exploits that we know for a fact have been exploited. That's the basis of it. The features we use are Twitter mentions about the CVE ID. It's these sets of keywords. It's the presence of exploits that are similar to this one in GitHub, in Metasploit, in a bunch of things. It's fairly similar if you've used EPSS. It's fairly similar. Our numbers are fairly similar to EPSS in terms of accuracy. And now you might ask me, why the hell did you develop your own model instead of contributing to EPSS? I work in cyber insurance, and we're in a highly regulated industry, meaning when I file our insurance filings, I need to tell regulators in the US how I'm scoring these companies to price their cyber insurance. So EPSS is still very much a black box model, and I don't know when things go in, how they're gonna come out. Here, I know how things work end to end, and that's why we built our own version. We have a new model coming out in potentially end of January that is looking a tiny bit more accurate than EPSS, so fingers crossed. Anyone else? Oh, Dinesh.
Yeah, and great presentation, great use cases. I had a question in terms of using customized models versus the RAG stuff, where you feed into the model, especially taking into account that now we have 128K of context to feed a huge amount of data. Do you see a world where we're going to be using mainly the context, especially as it gets bigger, and we don't need as much to create those customized models because we can be better at creating context, even with models feeding the models to feed the context?
I think it's going to be dependent on some research that OpenAI and Google have ongoing right now, where instead of retraining the full model, the whole thing about RAG is that you don't have to retrain the model, which is a super expensive process. But they're now doing research into a type of process where you retrain batches of a model, and you can essentially make cumulative batches to the original model. If that happens to work, I don't think we'll need RAG anymore, because just essentially retrain a couple of batches, send it to the cumulative model, and you have a nice model that works for everything. But I think it's highly dependent on what comes out of that.
Very good.
Thank you. And by the way, again, this only started 1 year ago, and this is where we are today. I'm super excited about where the next 5 years are going to take us. Oh, one more question back there.
One more.
Hi, thanks, Tiago. You mentioned the challenges of working in insurance and it being a very regulated industry. Have you run into any friction being able to leverage capabilities like this, as oftentimes regulated industries have to have very kind of simple, explainable models, and this really kind of goes out the window with LLMs?
We do. So if you break insurance into smaller parts, you've got risk selection, risk pricing, risk maintenance. We have no problem whatsoever using machine learning models in risk selection and risk maintenance. Super troubling to use it in risk pricing, because regulators do not like us. They worry correctly about these models being heavily biased towards something that might essentially exclude some industries or some types of companies to higher prices or lower prices. So in pricing, it is still a bit of a struggle.
Any more questions?
Well, oh, I think we have one up there. I was going to thank you all, but I have one more.
Hi, my question is related to how do you deal with data poisoning to keep the consistent results?
We don't because we haven't ran into that issue just yet. Right now, for our in-house trained models, we know where the data is coming from, and we're the ones training it, so we don't need to worry too much about data poisoning. And honestly, it's emails from brokers, it's emails from our customers, so we're not super worried. On the other side, where we're buying it as a service from OpenAI, that's what we're paying them for, and they should worry about that.
Well, if you're using Twitter data, X, whatever, I can guarantee that data poisoning is an issue that you'll have to look into.
Yeah, but so we're using Twitter data, not with LLMs and not in this way. It's a feature into a bigger model. So our Twitter data is not used for our LLMs.
Understood.
One last question.
Anything? Oh, one here in front.
Just a small question here. You are using a RAG as part of to feed your LLM. Have you tested fine-tuning to see the differences, understand if it could be a better approach in the future?
Yeah, we do and we don't. I mean, it depends on the use case. In certain situations, it is better. That's why I try not to be too binary about this, because it really depends on the use case and what you're trying to do. So for example, for the models that we have that are open source and we wanted them just to handle a specific use case from our customer emails. We found that fine-tuning would lead to better accuracy and made the model faster as well, because you don't have the delay from dealing with RAG, meaning going into the knowledge base, converting the embeddings, feeding them into the LLM. So for that, we went with fine-tuning. For other things like the vCISO, we went with an agent that combines RAG with the agent tools. It really depends. It's an analysis. As you're starting a project, you need to think about what is the project that I'm working on and what are the right tools to use. There isn't a binary answer, in my opinion.
This will be the last, I hope.
Hey, Tiago, great presentation. Thank you. Are you looking to make ESS available for the general public or just your clients?
Yes.
And
so the plan for ESS is right now, you don't need to register, you don't need to do anything. You can just go on the website and browse. We are going to be making API available in January, no authentication, nothing, open for everyone. I also want to publish a paper to be fully transparent about how ESS works, probably in the first quarter of next year.
awesome. And are you looking for your clients to be able to give context about their environment? So this could potentially help with patching prioritization, for example?
So we have a platform called Collision Control. Let me see if I can. Let's see if this opens here. So every client gets access to this. And if you go here to security findings, we give a list of essentially vulnerabilities the company is exposed to. We are going to change this in the first quarter of next year. We've built something called an asset classifier that does not use LLMs, uses machine learning but not LLMs, that essentially looks at the assets we have found for the company and tries to understand the role the asset plays in the company. Yeah. Then it crosses that data with our ESS scores and essentially combines these two things to give vulnerability management and vulnerability prioritization for our customers for free in the platform. Awesome. By the way, if you're looking for attack surface management platforms, this is free, zero cost, sign up, you'll have nothing to lose.
Awesome. Thank you so much, Tiago.
Cool. Well, thank you, B-Sides. Enjoy the rest of the day.